to draw a cash flow diagram with approach number 1, part A, with the least common multiple for machine A and B. The useful life of machine A is 6 years, machine B is 9 years. So the LCM, least common multiple, is 18 years. So how can we draw cash flow for each? So let's go with the machine A. For 18 years, how can we draw that? Then we start 18 years, year 0, and we basically replicate 6 years for another 2 6 years. So with that we have 6, 6, we have 12, and we have 18. So how can the first 6 years should be you should be familiar with how to draw the cash flow diagram. 18,000 initial costs, annual operating costs 3,500 per year, so that you have from year 1, 2, 3, 4, 5. 3,500. So that 3,500 per year for 6 years. And then at the end, the service value is 1,000. So that go up 1,000. The next issue is how can I draw another 6 years and another 6 years? How can we do that? Very simple. In this least common multiple method, approach 1, we assume the same cash flow occur in the first cycles, first life, replicate for the next and the next. So what does that mean? It means that we assume that we can, after year 6, we sell the first machine A, we buy the new machine A with the same amount of money, with the same operating costs, and the service value at the end of the second cycle will be the same. What does that mean here in cash flow? At the end of year 6, after I sell the first machine A, I buy the same amount. As you can see, it may not practical, but that's what the method approach 1 it should be. So that is, we have 18,000, I buy the new machine, and then I will spend operating cost from 7 to 12 with the same amount. So it will be 8, 9, 10, 11 for another 6 years, for 8,000, for 3,500 per year. And at the end of year 12, I sell that with the same service value, 1K. And similarly, I replicate that, the same for the last 6 years. I buy the third machine A, and then I have to generate the operating cost, 13, 14, 15, 16, 17. Same amount, 3,500 per year for operating costs. And at the end, I resell that for 1,000 service values. And similarly, you can do the same for machine B, which is years, and machine B 9 years. So we replicate one time. 0, 9 years, 18 years. 1, 2, etc. Then we can have spending 18,000 first year, 18,000. Annual cost 3,500. So let's put down 3, 4, 5, 6, 7, 8. At the end, I resell for the service value 2000. And that's the same cash flow replicate for the next 9 years. So that should be 10. Similarly, 10, 11, 13, 14, 15, 16, 17. What does that mean? I buy the new machine B at the end of year 9 for 18,000. I have to spend the annual cost the same amount, which is 2,500 per year, and then the service value 2,000 at the end of the cycle. So do the same over and over. At the end, we'll have that is 2,000. So from that we can have the NPV for each one. So let's see the NPV for machine A, and you can see NPV for machine A. So that become easy when we draw the cash flow diagram. So we have it 11K negative for A, and then the 3,500 per years from year 1 to year 6, 7 to year 12, 13 to 18. It means that 35,000 per year for all 18 years. So that basically it will be 35K, and the factor is same amount over the years. So A, we want to find out the PV, present value. So given A, 5P, P over 8, the 12%, the MA that we have, the MA here, 12%. So we have 12%. And the 18 years. And then we have year 6, we have to spend, you see, change that one. This should be 11. It should be 11. And should be 11. For A, we only spend 11. So at year 6, I spend 11,000 and service value is 1,000. So with that, we can have a negative 11,000, but I receive 1,000 service value at year 6. So minus 1,000, and then time the factor. It will be one single amount at year 6. So P over F, 1 to present value, 12%, and then we have 6 years. Similarly, at year 12, we can also have negative 11,000 minus 1,000 received, and then the factor is P over F, 12%, 12, year 12. So that is the amount here. And then the last one, 18, we have 1,000. So it will be plus 1,000. One single amount at year 18, print to year 0. So P over F, 12%, 6. So with that here, we go to the reference here, and look for the 12%. Look for the 12% here. So you have that is 12%. P over 8, 12%, 18 years. So this is 18 years. You have 7.2497. P over A for 6 years. P over F for 6 years. 0.5066. P over F for 12 years. 0.2567. For 18 years, and that P over F there, P over A there, that's what we do, 0.13. So from that, we can go back here, we can replace the number that we have, which is 7.2497. This one is 0.5666. This point P over F 12%, 12 equal to 0.2569. 67, and then this is 0.5666 13. So from that one, we can have NPV-A equal to negative 43,087,895. And the same process you can apply by now for the NPV for machine B.